Welcome to today's webinar, Next Gen Switching for Hyper-Converged and Multi-Container Environments. My name is Greg Holzrichter. I'm the Chief Marketing Officer here at Big Switch Networks, and I'll be your host for today's webinar. Joining me today is Doug Murray, President and CEO of Big Switch, as well as Prashant Gandhi, Chief Product Officer, as well as Jim Duffy, Senior Analyst at the 451 Research Group. As we go through the presentation, please feel free to ask questions using the Q&A box on your webinar dashboard. If you're watching this video in a rebroadcast or a recording, or if you have questions on an upcoming webinar topic that you would like our panelists to address, please just go to bigswitch.com/webinars and submit a question using the link provided. We've also provided you with handouts for today's session. You can download them from the Handouts tab on your dashboard. We have a full agenda for today's webinar, so let's get started. Our first speaker is Jim Duffy, Senior Analyst at the 451 Research Group. Jim?
Thanks very much, Greg. Good morning or afternoon, wherever you are. My name is Jim Duffy, and I'm a Senior Analyst for Networking at 451 Research. And I welcome you to today's webinar on the launch of Big Cloud Fabric 4.0 from Big Switch Networks. Next slide, please. Our agenda today will include some introductory remarks from me on the state of the data center networking market, some of the trends we're seeing here at 451, and the direction the market is heading. I'll share with you some recent end-user research we've done on the market and give you a perspective from the enterprise data center customer on what their particular plans and needs are. And then we'll segue over to Big Switch for a detailed overview of BCF 4.0 and how this new release of their software-defined data center networking fabric is addressing those requirements. Then we'll try to leave a bit of time at the end of the presentations for your questions. So the enterprise data center is going soft, and everyone's heading towards a software-defined data center infrastructure. Next slide, please. Okay, I'll start my stage setter with an overview of the SDN market, where commercially Big Switch is a pioneer. This and most of my data is from 451's Voice of the Enterprise Software-Defined Infrastructure Survey from the spring of 2016. The study includes more than 800 quarterly web-based surveys with IT end-user decision makers primarily based in North America and Europe. This slide right here shows the percentages of enterprise on-premises workloads running on SDN today and then in 2 years. The top 3 SDN workloads are security, unified communications, and industry-specific applications. But database and data warehousing will overtake both industry-specific applications and unified communications to become the number 2 SDN workload to security in 2 years. We attribute that to the huge amounts of data being churned through by analytics programs and the wealth of information that can be gleaned from them for optimizing and monetizing business operations. Next slide, please. These are some of the trends we're seeing in data center networking. Though SDN is the foundation of Big Switch's existence, specifically in data center networking and network monitoring, it's good to add a perspective of what workloads are running on an SDN to give the BCF 4.0 launch some context. Further context can come from a review of the data center networking trends as enterprises embark on these software-defined infrastructures and data centers. Listed here are the 3 major trends driving data center networking investment and vendor product development. Networks have to be hyper-convergence ready in order to support software-defined storage and provide visibility into the hyper-converged world for performance tuning, optimal network configuration, capacity planning, and others. Software-defined storage is also finding a strong use case in virtual desktop deployments. A data center network needs to be the backbone of those rollouts, so hyperconvergent support will soon become a must-have. Containers are a huge trend in data center networking as enterprises embrace this versatile application technology to support adaptable and rapidly provisionable microservices. The leading container orchestration systems are shown here, and support for all three will be key to enabling a data center network fabric to be the foundation of a containerized IT environment. And if VMs are already established as the workload du jour, there needs to be consistent orchestration between the VM and container environments in order to attain optimal performance in the mixed environment. The data center network needs to help mesh together these two worlds. Finally, the data center network fabric has to be elastic in scale. We're seeing the emergence of 25, 50, and 100G Ethernet from the leading silicon and switch hardware suppliers, and these will soon find a quick uptake at the leaf level and the spine level of the physical network infrastructure. Those architectures themselves will need to scale to support over 100 leaf switches as workloads and workload mobility increases and containers are mixed with VMs as the workload workhorses. So here are some of the software-defined infrastructure products in use today. And again, this is taken from our SDI survey last spring, Software-Defined Infrastructure Survey. Obviously, server virtualization dominates, given VMware's long incumbency as the leader in that market. Software-defined storage is next, followed by SDN and containers. And here's how these technologies are being adopted. This slide shows whether a particular SDI technology is broadly implemented, initially implemented, in test development, in pilots or trials, or just under evaluation. Software-defined storage, SDN, and containers are all broadly or initially implemented in 60% to 65% of the enterprises we surveyed. Here's a breakdown of the workloads supported by software-defined storage now and in 2 years. The two leading ones are unified communications and database data warehousing, with about 1/3 of survey respondents fully supporting them with software-defined storage. They will increase by about 15% in 2 years to roughly half of surveyed enterprises fully supporting them in software-defined storage. Security will increase by 11 to 12% to a little over 1/4 of surveyed enterprises supporting security workloads on software-defined storage. Next slide. Here's what we found when asking about primary software-defined storage vendors. VMware vSAN is tops by a considerable margin, almost 2-to-1 over IBM Spectrum Storage. Next slide, please. And here are the leading container management and orchestration providers according to our survey data. Docker, Kubernetes, and MUNICIPALITY are 1, 3, and 4, while Amazon's EC2 container service is popular too, at number 2. Next slide, please. As we saw before, scalability of the data center network fabric is key when considering deployment of containers and software-defined storage in an IT environment. The amount of data is only increasing, and the dynamic nature of cloud connectivity and east-west traffic patterns requires an infrastructure that is adaptable, flexible, rapidly provisioned, and bandwidth efficient. These requirements are why logical chassis fabric scale is doubling just about every year. That scale is also encouraged by developments at the chip and system level, the most recent of which is Broadcom's release of the Tomahawk chipset, supporting 25 and 50 gig and leaf switches. This in turn will spur migration of core and backbone switches to 100 gig from 40 gig, and from Broadcom's earlier generation Trident silicon. Inter-data center connectivity will be another driver for the Tomahawk and other 25, 50, and 100G chips and switches. Support for VXLAN tunnels will be key for facilitating secure and isolated east-west traffic flows and Layer 2 connectivity for use cases like disaster recovery, migrating from a traditional north-south network to a more dynamic east-west fabric, and for interoperability between multi-vendor fabric implementations. Thanks very much, Greg.
Thanks a lot, Jim. That was great for context and overview. And so without further ado, I'll go ahead and introduce Doug Murray, CEO of Big Switch.
Great. So Prashant and I are going to tag team on this. First of all, Jim, I wanted to take the opportunity to thank you for the excellent tee-up. As many of you know, Jim is a staple relative to coverage in the networking industry, and so we're thrilled to have you on the call with us today. In fact, I was reminiscing looking back at history. I think the first time I met Jim was at Networld Interop in the late 90s when I was working for AT&T. So it has been a long time and a long journey as this industry has continued to evolve over the last 20 years. I'd also like to welcome everybody else to the webinar here this morning, this afternoon, or if you're listening on the replay, thank you for joining us. So if you look at the discussion today that we're going to be having, that Prashant and I will be walking through, I just wanted to get you baselined relative to the discussion and Big Switch overall. So if you look on the right-hand side of this slide, it really reflects our big monitoring fabric, which is next-generation data center security and monitoring. We did a company launch back in December, which introduced what we're doing relative to our work in monitoring any workloads, specifically for AWS as well as the container space. We introduced the Big Secure architecture, which is getting a significant amount of traction and mindshare with our customers. And we also introduced BMF Release 6.0 with a great series of innovations. This webinar is not going to cover BMF today. The focus is really on BCF. So if you are interested in that product family and next generation data center security and monitoring, I invite you to go to our website, watch the webinar that we did in December, and learn more through some of the videos that we have there. Today we'll be focusing on next generation data center switching. And that is really our Big Cloud Fabric product, specifically our Big Cloud Fabric Release 4.0. And I will state this up front, BCF 4.0 is shipping today and is available for purchase via our partners. If we look at what we're going to be focusing on from a technology perspective, three key areas of innovation. First is with respect to hyper-converged ready networking. You can look at this as auto-configuration for vSAN networking and really allowing for simplicity in areas such as an example, one-click multicast. The second area that we'll be addressing in detail is with respect to containers. Jim brought up that this is something that we're seeing looked at and examined by enterprises and carriers around the world at this point, and we think we're in a position as Big Switch to serve as a leader in that segment. While nascent relative to that market itself, we think we're well poised to grow as that market grows. In this release in 4.0, we'll be supporting Kubernetes 1.4 with Docker 1.12, Mesos Data Center OS 1.8 with Mesos 1.01 containers, and Red Hat OpenShift version 3.3. So a lot of good work that's gone into that on the Big Switch side. And a lot of things that people are used to, such as test path, being able to look at flows of traffic throughout the switching fabric, being able to do so in a container environment. And Prashant will cover that in further detail. And then the last area we'll be discussing is regarding fabric innovations. And this is something that I'm remarkably proud of when I look at the engineering team and the product teams here at Big Switch and what they continue to do relative to innovation and the patents and IP portfolio that we're working through here. In 4.0, we double scale yet again to 128 leafs. And so by way of perspective, when we first launched BCF, we were doing this at the tune of 16 and 32 leaf and rack configurations. We then scaled that to 64. We're now scaling it to 128 leaves. That basically, just by context, that's the equivalent of having a work zone of 5,000 plus servers. So very impressive in terms of what we can do with scale and really scaling with Broadcom. We're also introducing inter-pod and inter-data center VXLAN support, as well as some advancements relative to integration with VSPHERE and their 6.5 release. And so a lot of good innovations with respect to what we'll be talking about today. And again, we'll go through these in further detail. Now, why do we do what we do here at Big Switch? So we really believe in this concept of next-gen data center networking. It is very clear via Jim's tee-up or any CIO or prospect that we talk to that the data center is going through transformation. And a key part of this transformation must be networking. And if you look at this change that's materializing, this metamorphosis, if you will, that's happening in the data center, you have to look at this across applications, across orchestration vehicles. You have to look at this relative to security. And then, of course, you have to look at this relative to how you want to achieve business velocity relative to applications and services that one would be deploying. Yet at the same time, people are keeping budgets flat or actually taking them down. As a matter of fact, I was meeting with a customer who's a financial in New York last week, and they're sharing that they have an objective of cutting their spend by $1 billion over the next 3 years. So in some cases, it's actually really about driving down cost. Now, as part of this, the network becomes the barrier, right? So the days when we were at Net World Interop back in the late 90s, a lot of the design principles that were leveraged at that juncture are still largely being used today. So the creation of networks really around opaque box-by-box networks that really haven't materially changed since about 1996. And so as a result, this really requires a different way to look at the network, a different way to look at the data center relative to SDDC. And that's why we look at things relative to next generation data center network. Our customers tell us that they really want to see intelligence. They want the ability to have one logical switch that manages their entire data center or segments of their data center. They want agility with things such as hitless upgrades. They want automation. They want deep visibility into what's going on with their packets and what's going on with their VMs and their containers. And they want flexibility. Gone are the days of being wed to one specific vendor. It's really about allowing for choice relative to hardware platform, separation of hardware and software, the ability to do so in both brownfield and greenfield environments, and really having the ability to choose. And when we talk to customers, that is paramount with respect to where they'll be taking their data centers in the next 5 years. And so at Big Switch, what do we do and how we do it? So we believe in disrupting the status quo of networking, and we do so by being the next generation data center networking company. What we do is we break this into various quadrants and use cases within the data center. It started with monitoring, with our big monitoring fabric, the next generation network packet broker. And then in 2014, we introduced the switching fabric, Big Cloud Fabric, which is the core of the discussion today. And what you'll see is over time, we've built upon very purpose-built use cases for these segments. So around areas such as the software-defined data center in partnership with VMware, OpenStack for carriers, where specifically they're delivering NFV workloads, the introduction of containers, which we'll talk about today, and then a series of things as it pertains to visibility and security on the network packet broker side. And at the core of all of this, the core of what we do architecturally is really rooted in the design principles we talked about early on in the history of the company. So the concept of separating the control in the data plane, leveraging an SDN controller, in this case, Big Cloud Fabric or Big Monitoring Fabric. The second key tenet being open network hardware, so choice with respect to the platform that it sits on, and that would be on the actual controller itself on the server or on the switches. And the ability to do things in a fabric-based architecture. So no longer box by box, only doing things in a fabric design. Now, customers ask me all the time, they say, so Doug, you guys are this SDN company, right? And in many respects, the way I answer that is, yes, we are an SDN company, and it's a very important part of our history. But in reality, we're a next-gen networking company, really, because SDN is a how. There is a series of things. SDN is a how, OpenFlow to a certain extent is a how as well. It is really about solving very specific pain points for our customers, and less about the fact that we're SDN, right? SDN is important, but it's, again, a how. An example of this, and just to share this, we have a report that's going to be published at Mobile World Congress that's coming up here in a few weeks in Barcelona. And what a third-party group did is they did a detailed analysis that we're going to be publishing of Big Switch versus legacy architectures specifically for carriers. And it was just fascinating what came back. So if you look at the breakdown relative to 5-year use of the infrastructure, carriers see the following. First, they see a 47% reduction in CapEx by using Big Cloud Fabric. 47% in CapEx, 57% in OpEx relative to how they operate the network. And at the same time, they reduce the time that it takes to roll out NFV workloads. They cut it in a third. So that's really why people buy the products, right? So they're doing it for the reduction of CapEx and really about simplifying how they deploy their capabilities. Now, key to this architecturally is not just SDN, but it's the way we think about the user experience. It's the way we think about integrations. And a very important part of that is our API first coding principle, right? So everything is about our REST API and having that go northbound. So if you look at it today, and this is not what many traditional vendors do, things such as our CLI and our GUIs are built on top of the API, right? And that also allows for portability with respect to platforms and integrations. I will share, if you haven't seen our GUI, I believe, is second to none in the industry. It is very elegant, and we see customers have these aha moments, not only in terms of the architecture, but the experience when they use the GUI. So I certainly invite you to spend some time looking at that. And really what this allows us to do by having this API first principle, this design model, is it allows us to move into different segments of the data center and attack various use cases as we go. So early on, the emphasis was on OpenStack in partnership with Mirantis and Red Hat. We quickly, as carriers adopted that, but then enterprises were looking at continuing to expand in the VMware world, as well as starting to look at early days of containers. We wanted the ability to take our technology into those markets, which we then did. And so this model allows us to have incredible portability across orchestration systems and platforms, as well as integration into custom environments at the OSS layer. So we believe that allows for a great deal of innovation and allows for customers to do things in a much more accelerated fashion. I want to conclude with just a little bit of highlight with respect to our customers. And I'm really proud of the logos and the customers that put their trust in our company every day. In 2016, it was a phenomenal year for the company. We more than doubled our software bookings. We also more than doubled the number of logos that we have relative to our customer base. While what we do is clearly cross-industry, we tend to see a lot of customers in the telecommunications, so the carrier space as well as cloud space, financial services, big tech companies, education, and the government side. So that tends to be the sweet spot with respect to where we fit. And if you look at our last quarter, just by way of example, in our last quarter we did more than 100 transactions across more than 50 customers, and actually won 25 new logos, right? So we certainly see the velocity picking up relative to the adoption of the capability, and we don't think that's going to end here in 2017. Our expectation and our strategy relative to investment is to indeed double the business again this year and double the number of logos. The other thing on this slide that you'll see is we have over 10 customers now, over a dozen customers actually, that have transacted more than $1 million with Big Switch. And no, you're not looking at a game of Tetris. You're actually looking at the flow of what we call land and expand internally. So if you look down the left, it's enterprise, and some of those enterprises are actually cloud providers that we just internally classify as enterprises. But you see enterprises, federal service providers, and so forth. And the way to look at this is the first dark blue box is the initial land. Some of those deployments are actually rather small, could be a $50,000 to $100,000 software transaction or deal. But what you see is that from a monetization perspective and an investment in Big Switch, once customers try the product, they continue to deploy it not only in the existing environment, but then expand the use across their enterprise or across their operator environment. And so what we're seeing now is the lifetime value of a given customer is growing significantly at a multiple of 10 to 20x, right? So that's a very important variable that we're tracking in terms of customer satisfaction, as well as what we're doing in terms of the build out of a land, expand, and renew software business. So I'll conclude by saying I invite you to go to BSN Labs, try the products. You won't be disappointed. The team has put a great deal of work into building what I believe are the leading edge products from a data center switching and network packet broker perspective. And for further details in terms of Big Cloud Fabric 4.0, and what we're announcing today, I'd like to turn it back to Prashant.
Perfect. Thank you very much, Doug and Jim, for setting the context in regards to what the data center trends are, especially going soft, very software defined, and also setting the context in terms of what we mean by next generation. And what I'll do in the rest of the product discussion piece is to concretize where intelligence comes from, what we mean by agility, and the level of flexibility that the architecture provides in bringing the level of innovation velocity that we have been able to accomplish over the past 2.5 years since the introduction of Big Cloud Fabric. So if we kind of go back and look at how infrastructure is consumed in the data center, we have traffic that comes in to the DMZ, which is then sent to application environment to consume application resources and data resources. Applications can be physical, virtual, or containerized. And this infrastructure needs to be fully monitored. And so oftentimes that traffic is replicated either through span or taps and sent to monitoring environment, where a variety of monitoring tools such as network performance management, application performance management, security monitoring, data recorders are attached to the monitoring infrastructure for providing those services. And in the DMZ, certainly the ability to place multiple services in tandem, in daisy chain, to be able to provide full security and cyber defense capabilities. So what Big Switch is offering, as Doug pointed out, a portfolio of products driven with a set of use cases in mind for the data center, and specifically software-defined data center opportunities. When we consider Big Cloud Fabric portfolio across the three use cases of VMware, OpenStack containers, and as generic fabric, it is placed to connect applications of any type of physical, virtual, or containers. And it can be deployed in brownfield data centers or greenfield, next to traditional data center network with ability to connect through their three core routers to interact between legacy and SDN-based Big Cloud Fabric. This infrastructure can be monitored, whether it is SDN-based, leveraging Big Cloud Fabric, or traditional box-by-box network. That entire infrastructure can be monitored leveraging Big Switch's Big Monitoring Fabric, which provides a way to aggregate span and tap traffic, the out-of-band traffic, to provide a variety of monitoring needs through our partners who provide monitoring tools and security tools. And finally, in the DMZ, where the inline capability of Big Monitoring Fabric is deployed in order to enable service chaining across security tools and provide very simplified change management across the network team and the security team, so that rapidly new experimental technologies can be deployed to combat the evolving cybersecurity threats that we are witnessing every day. And in conjunction, we have defined for service providers, cloud providers, for scrubbing centers, an ability through Big Secure Architecture to do a scale-out, very high-performance terabit DDoS mitigation in partnership with, for example, A10 networks. So with that sort of a perspective of how Big Switch products are deployed in the data center, let's go back and see what is it that brings intelligence and agility into this architecture compared to the 20-year-old traditional box-by-box infrastructure. And what we see is that the combination of SDN software and the open hardware and the fabric topology allows us to build a logical representation of a chassis architecture. So you get the ability to do rapid change management by adding leaf switches as line cards, spine switches as backplane fabric cards, and the controller as equivalent to a supervisor of a chassis, but without the baggage of those complex, scale up and expensive proprietary chassis architecture. So here, one is able to leverage open networking switches, a very scale-out architecture, but operate it as if it's a redundant pair of logical chassis architectures controlled by software controllers, SDN controllers. And so there is no more the challenges of spanning tree and the performance bottlenecks of an L2 access and L3 aggregation network, and the complexity of the myriad of protocols that one needs to enable on a box-by-box basis, which makes the network very brittle, very difficult to configure because of the manual workflows that are there. And God forbid, if something goes wrong and application connectivity or performance issues are experienced, then one has to go box by box by box to hunt and hop to be able to figure out where the problem is. Instead, what Big Cloud Fabric provides is a very logical, unified approach to switching, where multiple switches operating in a fabric environment, a leaf-spine environment, operates as one logical switch. So you get a very scale-out architecture. We can deploy L2 or L3. There's no need to have design choices. You get best of both worlds, completely zero touch, and of course choice of hardware vendors. And with an SDN controller, one gets a single pane of glass to operate from. The protocols are configured only at one place, so BGP only runs on the SDN controller. One does not need to enable BGP, or there's no spanning tree in the fabric, so there's no need to configure that and worry about the performance issues and the stability issues of spanning tree-based architectures. So that simplicity is provided because of this ability to centrally manage the entire environment, logical environment. And finally, the ability to drive operate the solution, the entire fabric using intent, leveraging APIs, and having that deep visibility through built-in analytics that the solution provides. So what does it allow us to achieve? With intent-based networking, one does not worry about the 20 different workflow steps that need to occur in how one configures the product, but one can express the intent in terms of what an operator wishes to do, such as add a leaf or a spine switch, add a VM, upgrade the software, or audit application connectivity. And these issues can be expressed at a higher layer, and we let the controller and the machines implement the workflow steps that are not that are very manual in a box-by-box network. So intent-based becomes very important, and I've outlined a few of the intent-based workflows here. But Big Cloud Fabric's whole architecture is that every capability that we have, we want to avoid operators, network admins from doing manual multi-step process, that we express these capabilities at a higher layer, add a server, and automatically the network gets configured. Add a VM, whether it's a container or a VMware VM or an OpenStack VM, and the network gets automatically configured. Similarly, app connectivity. If one wants to audit whether an app is supposed to communicate with one another, very easy to see that and troubleshoot that. And we will see some of these capabilities as we drill down further as part of this launch. And the outcome, Doug pointed out some of the recent study in the benefits for NFV. Here, in general, ACG Research has done a study where they've shown the operational benefit as well as the CapEx benefit, really 10x operational benefits, 4x application deployment ability to speed up, and significant savings. We've seen customers save up to 50% on their CapEx environment. So significantly different in terms of the way the architecture is built, the way customers experience it, with the aha moments that they have compared to the traditional box-by-box network that they have operated for a couple of decades now. So with that, let's jump into the innovations. we are going to focus on VMware, innovations in VMware, and here we have doubled down significantly over the past couple of years with integration into vSphere, visibility for NSX, so there is no more overlay-underlay visibility gap for the network admin. We are extending it to vSAN, and you'll see us now add additional deeper visibility for hyper-converged environment, specifically vSAN. Support new use case, VMware Horizon VDI, which we see multiple customers deploying alongside with vSAN, and support for vSphere 6.5. Container is a new use case that we are now focusing on, and we started with Kubernetes, and we are now supporting Red Hat, OpenShift, and Mesosphere, and the level of integration that we will talk about, where it's completely zero touch. An orchestrator creates a VM, or an admin adds a server to the infrastructure, and the rest of the provisioning visibility are automatically provided through the big cloud fabric. And finally, innovations. As Jim pointed out, the data center trends, performance is now moving from 1040 gig to 2500 gig. Big cloud fabric is ready to support that, so customers can bring in servers all the way from 1 gigabit to 25, 40 gigabit with a fabric that is 40 and 100 gig. Very large scale support for fabric. Earlier, there was this sense that perhaps SDN, would have, challenges in terms of scaling. But what we have been able to show very methodically is that we can double the scale almost on a yearly basis in terms of. So there's architecturally, it is ready to support very large scale data centers. And finally, ability to extend, layer 2 connectivity across pods and across data centers to extend tenants and workloads. Just in terms of looking at the two flavors of big cloud fabric, it is supported for VMware as a physical leaf-spine fabric. And for Linux environment, whether it's OpenStack or containers, we support both physical and virtual environments managed by the same controller. And this allows a very deep ability to provide visibility as well as troubleshooting when the network is managed through the controller for both physical leaf-spine as well as the OVS-based virtual switches. So let's jump into the specific innovations. In terms of Hyper-Converged, we have been supporting vSAN, and there are tremendous benefits that big cloud fabric brings for vSAN. Specifically, vSAN nodes, when they're added to the network, are automatically configured on the leaf-spine fabric. vSAN requires multicast to be enabled. It is because of the logical chassis nature of the product. It is simply a one-click way to deploy multicasting across the entire fabric. And now we're bringing cluster-level visibility and a very dedicated vSAN dashboard right into the SDN controller through API integration, so that network admin have visibility to not just the VMs and the virtual switches and the vMotion events, but also storage capabilities, specifically cluster-level information. So how does this work? This intent-based networking, how does it translate to in terms of the actual operational workflow? So here's some examples that we will walk through. Let's say a vSAN node is added, or any ESX node is added to the fabric. When the node is added, it automatically is shown in the big cloud fabric controller, and specifically how the connection takes place between the server NICs to the leaf switches and the exact port numbers to which the connectivity has been enabled. There's no administrative intervention is required. This is all done automatically and shown immediately into the big cloud fabric. Once the host is admitted to the fabric, all of the host level details are provided, including, and again, automatically, there is no manual intervention, including the host name, the OS that runs on the host, including CPU and memory utilization. And finally, endpoints. As VMs are configured, one can see their state, whether or not they're powered on from a vCENTER perspective, whether or not they're learned in Big Cloud Fabric, and what potentially the issue may be in the event that they are not connected to Big Cloud Fabric. So ability to have the intent, verify the intent on a continuous basis, and then provide perspective or errors and warnings to as a way to remediate the issues. Also, the network, the L2 segments such as VLANs are automatically configured when VMs are attached to the network. And here's the view of analytics. So what happened to application performance at 2 in the morning? One can go to the analytics dashboard, see the details about the virtualization environment. There is clear dashboards available for vCENTER, whether it's vMotion or NSX and now vSAN, and cluster level information is now very visible within the analytics dashboard. VDI is now a first-class citizen on Big Cloud Fabric. As VDI is deployed along with vSAN, all of these benefits are extended to VDI VMs, including ability to search VMs based on the guest OS. So now one can say, find VMs that have Windows 10 or Windows Server 2016, or even an older version of Windows Vista. One can easily identify those VMs. And specifically, the Horizon workloads are also identifiable, and a great way for a network admin to see that these applications are connected and operating as intended in the network environment. So some customer perspective. Dubai Municipality deployed. We have been working with them for a couple of quarters now, and they've deployed Big Cloud Fabric across multiple data centers and for the VMware use case, and they see great opportunity to extend this to a variety of use cases that they would like to deploy as they usher into modernizing their infrastructure to software-defined data centers. They've seen migration costs, for example, reduced by 90% from what they had originally intended. So high performance, lots of simplicity and operational agility, and reduction of cost are the benefits that they were able to immediately realize as they deployed the Big Cloud Fabric. So with that, let's jump into container networking. As we interact with customers, they have these aha moments as they deploy VMware workloads, OpenStack workloads, and then now the question is, is this infrastructure, this architecture ready for containers? And what we have done is, with the ability to control both physical and virtual environment, especially for Linux workloads, we are able to provide the same network automation that we saw for VMware workloads to container environments. And here, it's not just Kubernetes that we are supporting. We are showing the ability of Big Cloud Fabric to bring innovations rapidly by showing that we can support multiple orchestrators, including MUNICIPALITY and Red Hat OpenShift. So how does this happen? And really, the core of this is, as Doug earlier pointed out, is through plugins and API integration. So with this logical network that is built using leaf-spine and virtual switches, one simply has to add container plugins to be able to deploy containers and automate the network and provide visibility. So all we have to do in this environment is simply drop in a container agent for MUNICIPALITY or Kubernetes or OpenShift, and then a host-based plugin that is CNI capable or libvirt capable to be able to support any runtime environment, whether it's Docker or Apache Mesos. And so some examples of now intent being deploying containers, and let's say one wants to see if container connectivity is provided, and one would, on a box-by-box basis, go from a virtual switch to leaf to spine, specific ports in an MLAG or lag configuration to figure out, how connectivity check would occur, or during troubleshooting, the steps that would, many steps that would be needed to take place to understand this connectivity. Here, by simply taking a click of a button with test path, we are able to show the full visibility of traffic flowing through across the containers. Very easy to see, very quickly to troubleshoot, and also audit the intent for container level connectivity. If a server is added, such as OpenShift node, as we saw earlier in the VMware case, the same capability is extended. Server is automatically configured for its connection to the leaf switches through MLAG or lag, and the containers are automatically brought into the controller environment for visibility, and network is automatically assigned. Their names are detected and shown as well. And finally, analytics for containers. So if something happens at 2 in the morning, one can see these events. We have a container dashboard available in analytics. All the logs and events are captured so that you can replay for the past many days and get the information about containers and issues potentially related to containers. And finally, a really groundbreaking capability that Big Cloud Fabric provides, which really is another sort of testament to what is next generation networking. You've all seen networks provide multi-tenancy, but can network provide multi-tenancy across multiple orchestrators in an isolated manner? And that's what Big Cloud provides. Big Cloud Fabric provides as part of the virtual pod capability. You can deploy, take a physical pod network and carve it out into multiple virtual pods and deploy a variety of orchestrators. So here, example, you can have VMware, NSX, vSAN as different vPods. Alongside with it, OpenStack workloads can reside and be automated through OpenStack orchestrators, Red Hat or Mirantis, and similarly containers. So now a customer can deploy a cloud environment or set up dev and test environments, or in the case of containers and cloud native apps, carry out CI/CD workflows with a common physical infrastructure for networking and leverage this isolation across vPods to be able to optimize and really simplify deployments across multiple orchestrators. Very unique capability, and we believe it's a industry first with Big Cloud Fabric. Our customer, YouTube Cloud, has deployed 20 such vPod instances to provide multi-tenant, multi-orchestrator services to their enterprise customers. We talked about Fabric innovations. In the interest of time, I'm going to stop here, and we can go to Q&A.
Fantastic, Prashant. Thank you so much for that overview and deep dive into the integration with VMware workloads as well as container networking. It really is a very differentiated solution. And as Doug mentioned earlier in the presentation, we encourage you to visit by pointing your browser to labs.bigswitch.com. Very easy to sign up, and there's 12 distinct modules that allow you to experience firsthand both the Big Monitoring Fabric as well as Big Cloud Fabric, as well as integrations. So highly encourage you to do that. We also have a library of recorded webinars. If you go to bigswitch.com to the Resources tab, there is a very rich list of both videos, written assets, as well as recorded webinars. And always, we would be happy to speak with you live. So feel free to send an email to sales@bigswitch.com. With that, I'd like to take a look at the Q&A section. It looks like we have a question around OpenStack and Docker. Can I do Docker stuff without having OpenStack? Here's the question.
Yes, absolutely. These can be completely decoupled use cases. So if you'd like to do Kubernetes orchestration with Docker runtime, that can be easily deployed. There's no requirement to deploy OpenStack. That is an independent use case, fully supported by Big Cloud Fabric. And we have actually videos, demonstration videos on our website to show how Docker based containers can be deployed with Kubernetes or Red Hat OpenShift.
Fantastic. That's great. Looks like we have another one here. Can you give us an example use case of where containers and VMs would be mixed and require multi-orchestration?
Multiple use cases. So in the case of U2 Cloud, the customers, the cloud provider is offering managed private cloud services, and it allows them to offer, for example, a vSphere per customer. And so you have multiple vSphere instances that are simultaneously integrated with the same big cloud fabric controller, and the network automation and visibility is provided, even with overlapping network addresses such as VLANs and overlapping IP addresses. So very easy to do that. Now, let's say you have a dev and test environment, and you'd like to do the testing across VMs as well as multiple container orchestrators. vPod allows one to do that very easily, deploy one network, one infrastructure, and simply logically associate multiple orchestrator to that, so that you can have not only you can have VMs of variety of types, containers, even bare metal workloads can be attached, and this unified environment allows reduces cost significantly, both operational and capex cost.
Can I ask a follow-up to that?
Please do.
Are there any standards, container networking standards, either defined or on the horizon for that multi-orchestration capability between VMs and containers?
So there are standards defined at the network layer that we leverage. So underneath it, as we define this logical environment such as vPod, it is associated with virtual router function, the VRF, from a network perspective. It associates with multiple L2 segments, whether for example VLANs, and associates a set of ports in the fabric. And this in combination of that, along with the policy and configuration isolation, we are able to define vPod. Now, in the container environment, there are specific standards that we adhere to, such as CNI, Container Network Interface, and CNM, so that it allows VMs to be resident on the same fabric in one vPod, and a set of containers to be residing in another vPod. You can have multiple containers residing across vPods to be able to do use cases like CI/CD, continuous integration and continuous deployments.
Okay, thank you.
Great, Prashant. So we actually have another question regarding VMware NSX deployments and BCS, and maybe you can comment on our partnership with Dell in the context of Dell hardware NSX and how customers deploy in a variety of deployment scenarios.
Absolutely. With our integration with VMware, what we have done is really focused on supporting all VMware SDDC environments, whether it's vSphere, NSX, or vSAN. And so in this case of NSX, as NSX nodes are added to the fabric, they get automatically recognized. We show VTAP visibility in the controller fabric so that a network admin can has the complete overlay understanding with the underlay big cloud fabric controller. So VMs associated with logical switch, associated with VXLAN, all of this information is visible in our analytics. And so there's no really overlay underlay gap. And our approach is to continue to integrate. So we've shown interoperability integration with hardware VTAP, and we have a video demonstration available as well. So multiple customers who have deployed NSX on top of big cloud fabric underlay, and customer can purchase the entire solution from Dell. So Dell hardware switches, our software, as well as the VMware assets directly from Dell. So very simple way to not only build the SDDC with big cloud fabric and also have a very simple way to procure this capabilities.
Fantastic. Yeah, and just building on the specific question, it's not a requirement for customers to go down the path of NSX, but if they do, then we're the ideal SDN underlay, physical network for NSX, and for those who are just doing general virtualization workloads, Big Cloud Fabric does provide automation and benefits of this next generation approach. It looks like there is another question here around questions around Nutanix. So I use Nutanix. Are you planning to support them as well?
Yeah, so as you look at the partnership with VMware and vSAN, we went there first quite logically, as Jim rightly pointed out, just in terms of use in the survey. vSAN is at the top of the list, so that coupled with our strategic partnership with Dell and VMware lends itself to going there first. I assume that over time, as the hyper-converged world continues to evolve, that we'll be in a position to be able to support other solutions over time, but currently our emphasis is on vSAN and our partnership with VMware.
And we have customers who have deployed Nutanix.
Nutanix as well.
With,
absolutely correct.
And so, that is a use case that is already in place, and we have partnership with Nutanix.
We do.
And we will be working to provide additional benefits through our integration into the Nutanix environment.
Yes.
Fantastic. Here's another question about sort of multi-data center and how do we look at multiple data centers and pods.
Yeah. The very unique aspects of Big Cloud Fabric is that it can be deployed on a pod-by-pod basis, just like the way hyperscalers are scaling out their data centers. So in the enterprise and the service provider environment, same principles are adopted, and so now one can scale on a pod-by-pod basis. These pods can be distributed across data centers and connected through VXLANs, L2 extensions across data centers. So now customers have an opportunity to migrate workloads, leverage interconnectivity through VXLAN across data centers to be able to support disaster recovery use cases, ability to stretch tenants across data centers. So all of these use cases are supported, and really depending on what the customer is looking at, it can be workloads that are such as VMware and OpenStack and containers, or it could be workloads such as NSX that reside as an overlay on Big Cloud Fabric underlay.
Fantastic. Thanks so much, Prasanth. So that takes us to the top of the hour. Lots of good questions. We thank you all for joining this webinar and for listening if you're listening in a recorded mode. And we are, with that, going to wrap the Big Switch Big Cloud Fabric 4.0 launch webinar. Thank you all for attending. And as I mentioned earlier, if you would like to get started, we have BSN Labs, as well as a free community edition, which is fully functional software that you can deploy across a variety of open networking hardware. We have a hardware compatibility list that is listed on the site, and we encourage you to take the product for a spin in your own lab. With that, we will go ahead and wrap. And one final point of housekeeping. We do have a sponsored webinar being hosted by SDX Central around next generation networking, drivers, and customer use cases, which is scheduled for Wednesday, February 22nd at 10 a.m. And we'll be sending out a link to that along with follow-up materials to everybody who is attending this webinar. So with that, thank you for your attention and interest in Big Switch and next generation networking.